Everybody demonstrates that Claude can read a chart. Almost nobody says how accurately, because saying so requires actually testing it. So today, what Vision is really doing when it reads an image, a scored test against numbers that were hidden until afterwards, and then the one limit that matters, which turns out not to be a limit of the model. First, what it's actually doing, because reading text out of a picture is the least of it. Reading characters out of a picture is the least interesting thing it does. Because it isn't reading text out of an image. It's reading the layout. Which column a number sits in. Which label belongs to which bar. What an arrow in a diagram is pointing at. Which line of a stack trace is yours, and which is the framework's. That's structure, not characters, and it's why a screenshot of a table comes back as a table. One practical thing. The current models handle high-resolution images, up to about 2,500 pixels on the long edge. A bigger screenshot means more detail read and more tokens built, so cropping to the part that actually matters is both cheaper and usually more accurate. So the habit to break is describing things you could show. People screenshot an error and then type the error. They look at a chart and then summarize the chart in words. Every one of those is a lossy translation you performed for free and got wrong slightly. Give it the picture and let it do the reading. And in a minute I'll show you exactly how accurate that reading is, because I tested it. Second, the test. Generated numbers, hidden, read off a picture, then scored. No demo magic available. I wrote my readings down before opening the answers, which is the only part that makes it a test. 8 bars. Values generated at random and written straight to a file I didn't look at. Then I read each bar off the image against the grid lines, wrote those down, and scored them. The ordering matters. Reading first, opening the file second. Reverse it, and you grade yourself generously without noticing. Mean error, 0.6%. Worst single bar, 2.4%. All 8 inside 5%. Then I made it harder. Same test, but I stripped the grid lines, the axis, and the scale off the chart entirely. And this is the result I did not expect. With no scale at all, the ratios were still almost perfect, every bar within 0.5 percentage point of its true proportion. But the absolute values? 0 out of 6. Not approximately, not roughly. 0. And that isn't the model being weak. Those numbers were never drawn on the chart. It read everything the image contained, which is exactly what it should do. And third, the failure case, which is genuinely not the failure people assume it is. I got 0 out of 6, and I'd argue that was the correct answer. When this happens, people reach for hallucination or vision being unreliable. But look at what actually happened. The chart had no axis and no scale, so the numbers genuinely were not in the picture. The ratios it could see, it got right to within 0.5 percentage point. It read everything that was there, and the thing that was missing from the image, not from the model. 0.5 percentage point on every single bar, with nothing to measure against but the other bars. So the useful habit is to ask, before you send a picture, does this image actually contain the answer? A screenshot of a chart with no axis doesn't hold the numbers. A photo of a page with the crucial column cut off doesn't hold the total. A blurry receipt genuinely doesn't hold that line item. When you get a confident wrong answer from an image, the first question isn't whether the model is any good. It's whether you sent it something that could have been answered at all. It's the same question you'd ask a person. If I handed you that chart and asked for the numbers, you'd tell me the axis was missing. And you can run this on anything, not just charts. The method is the important bit, so here it is properly. Generate the answer first, and write it somewhere you won't look. Produce the thing you're going to test against, the chart, the document, the screenshot. Record your reading before you check. Then score it. That ordering is the entire experiment, because if you look at the answer first, you will unconsciously grade generously every time. It is the difference between a test and a demonstration, and almost everything posted online is the second one wearing the clothes of the first. 3 things to take away. It reads structure, not characters. So give it the screenshot rather than your description of the screenshot. It is genuinely accurate on anything the image actually contains. And when it's wrong, check the image before you blame the model. The thing I'd genuinely take from this week is the method rather than the result. Hiding the answer before testing costs about 30 seconds, and it's the only thing standing between a test and a flattering anecdote. I have caught myself grading generously more than once on this channel. And the only reason I know the chart numbers are real is that the file was sitting there unopened while I wrote my readings down. And if you only remember one line from this, a confident wrong answer from an image is usually a question the image could never have answered. That's day 9. 3 shorts every day and a full cut like this each evening. Subscribe if it's useful to you. Tomorrow, getting the output in the exact shape you asked for.